The Agulhas Basin is an oceanic basin located south of South Africa where the South Atlantic Ocean and southwestern Indian Ocean meet, part of the African Plate. It is bounded by the Agulhas Ridge to the north and the southwest Indian Ridge to the south, by the Meteor Rise to the west and the Agulhas Plateau to the east. A large number of bathymetric anomalies hints at the basin's dynamic tectonic history. Geology. In a late Paleocene reconstruction of the opening of the South Atlantic Ocean, the Meteor Rise lies conjugate to the Islas Orsadas Rise. The separation of the Meteor Rise and the Islas Orsadas Rise marks the beginning of the formation of the Agulhas Basin. The Agulhas Ridge extends from the northern tip of the Meteor Rise towards the Agulhas Bank south of South Africa. The ridge, however, ends abruptly in a small plateau at 40 degrees south, 15 degrees east, -40, 15, where it intersects a northeastward trending spreading center that was abandoned. During the early Paleocene, the presence of a short-lived tectonic plate between these structures was first proposed by Labreck and Amp Hayes 1979. They named it the Malvinas Plate and proposed that it was active from 90 Ma until the spreading ceased in the Agulhas Basin at 65 Ma. The plate is located at a proto-Bouvet triple junction. Marks and Amp Stock 2001 found that late Cretaceous fracture zones generated on the Agulhas Rift do not align with those north of the Agulhas fracture zone and cannot therefore have been formed by the spreading of South America and Africa. Furthermore, magnetic anomalies on the Malvinas Plate do not align with the conjugates on the African Plate if the spreading rates in directions of South America and Africa are used as a guide. They also noted that the Agulhas fracture zone do not lay perpendicular to traces of the South America-Africa spreading north of it and cannot, therefore, have been generated by this spreading. The Agulhas Rift is the abandoned Malvinas Africa Ridge crest. 97 Ma. The plate boundary in the Agulhas Basin was reorganized when the Mid-Atlantic Ridge made an eastward jump. This brought the boundary towards the Agulhas Plateau, where excessive volcanism was building a large igneous province. The inception of the Malvinas Plate accompanied this shortening of the Agulhas fracture zone. 61 Ma. The Malvinas Plate was finally incorporated into the African Plate when the Malvinas Africa Ridge was abandoned as the result of a westward ridge jump along the Agulhas Falkland fracture zone. This second ridge jump reduced one of the most spectacular fracture zones in Earth's history, 1,200 kilometers in length, to 180 kilometers. Oceanography. The Agulhas current flows south along the African east coast. When it reaches the southern tip of Africa, it retroflects back into the Indian Ocean. At this retroflection, it leaks warm core eddies known as Agulhas rings into the South Atlantic. This mesoscale anticyclonic rings feed the Atlantic meridional, overturning circulation and therefore believed to affect the global climate. Although the connection between the leakage, AMOC, and climate change is still poorly understood, in the Agulhas Basin, half of these rings are subdivided one or several times. A majority of the subdivided rings split at or near the bathymetric obstacles on the western side of the Agulhas Basin, but almost a quarter of them also merge there either because of the obstacles or because of intense interaction with other rings. Antarctic bottom water originated in the Oligocene with the opening of the Drake Passage and the Tasmanian Seaway and resulted in the thermal insulation of Antarctica. AABW mixes with other masses in the Antarctic circumpolar current to form the circumpolar deep water. In the Agulhas Basin, CDW flows northward and is deflected mostly westward by the Agulhas Ridge. A branch of CDW, however, enters the Cape Basin west of the ridge from where it flows west along the northern side of the ridge before being deflected northeast at the eastern end of the ridge. This long detour in the Cape Basin and mixing with North Atlantic deep water results in warmer water than other CDW masses. Antarctic intermediate water flows above the CDW in the Agulhas Basin in an anticyclonic path.